Welcome to this lesson on Vesic's bearing capacity method. We will build intuition about the ultimate bearing capacity of a shallow foundation, showing how Vesic extends classic Terzaghi-style formulas with a rich set of correction factors. Here is the complete general bearing capacity equation using Vesic's approach. Each term represents cohesion, vertical stress, or unit weight contributions weighted by the full set of correction factors. Let's define the parameters appearing in that equation. C' is the effective cohesion. Q is the vertical stress at the foundation level, and gamma is the soil unit weight. B is the footing width, and N sub C, N sub Q, and N sub gamma are the basic bearing capacity factors. The letters S, D, I, G, B are all correction factors for shape, depth, inclination, slope, and base tilt respectively. This diagram shows a shallow foundation embedded in soil. The top surface is the ground, the footing width is B, and the depth to the base is D sub F. The soil unit weight gamma acts everywhere, and the soil profile may have a slope beta or a tilted base alpha, depending on the situation. The N factors depend solely on the effective friction angle phi prime. N sub Q grows exponentially via the tan of phi prime. N sub C is derived from N sub Q and cot phi prime, and the gamma factor uses Vesic's formulation with 2 times N sub Q plus 1 times tan phi prime. Shape factors adjust for non-strip footings. For square or rectangular footings, we compare B over L. S sub C equals 1 plus B over L times N sub Q over N sub C. S sub Q equals 1 plus B over L times tan phi prime. And S sub gamma equals 1 minus 0.4 times B over L. Depth factors account for soil resistance above the foundation. Let K equal D over B. When K is less than or equal to 1, D sub Q equals 1 plus 2 tan phi prime times 1 minus sin phi prime squared times K, while D sub gamma equals 1. When K exceeds 1, we use an arctangent function and adjust D sub C to stay consistent with cohesion contributions. A load applied off vertical reduces capacity. The reduction factors I sub Q and I sub gamma use the ratio of the horizontal load to the vertical load plus the cohesion term, raised to powers m and m plus 1 respectively. Then I sub C adjusts from I sub Q with a subtraction involving N sub C and cot phi prime. Ground slope and base tilt also matter. When the ground has slope beta, G sub Q and G sub gamma both become 1 minus tan beta squared. When the base tilts by alpha, B sub Q and B sub gamma follow 1 minus alpha times tan phi prime squared. Time for a concrete example. Consider a square footing, B equals 2 meters and D sub F equals 1.5 meters, embedded in dense sand with phi prime equals 35 degrees, C prime equals 0, and gamma equals 18 kilonewtons per cubic meter. We assume no load inclination or slope. First compute the bearing capacity factors for 35 degrees. N sub Q is about 33.30, N sub gamma about 48.03, and N sub C about 46.12. Shape factors for a square footing with B over L equal to 1 give S sub Q around 1.7, S sub gamma about 0.6. Depth factor D sub Q uses K equals DF over B, that is 0.75. So D sub Q is roughly 1.19 and D sub gamma stays 1. Inserting numbers, we evaluate Q equal gamma times D sub F equals 18 times 1.5 equals 27 kilopascals. Plugging everything into the general equation with S, D, and the unity factors for I, G, B gives Q sub U around 2,338 kilopascals. Now consider the same footing but with a horizontal load of 200 kilonewtons and a vertical load of 1,000 kilonewtons. The ratio H over V is 0.2, and with 2 as the exponent m, I sub Q becomes 0.64, while I sub gamma becomes 0.512. Multiply the previous contributions by these inclination reductions. The cohesive term still vanishes, so the QB term becomes 18.700 by I sub Q, and the gamma term by I sub gamma, giving Q sub U about 1,429.9 kilopascals. In summary, this table shows the ultimate bearing capacity for both cases, and the effect of the inclined load reduces capacity by about 39%. Vesic's method keeps all of these factors organized so engineers can see how each contribution changes the ultimate capacity.